Data have always been at the core of investment. People have always sought to collect better information, to better understand company accounts, the likelihood of success of company products, the competency of management, or the effects of government policy. Yet in the last few years, we've seen an explosion of interest in the use of data in investment. Data science, and quantitative analytics have broken out from the specialist quant funds into the mainstream at the same time as computational capacity has increased. Collecting relevant information, making decisions based on evidence, having a process and avoiding behavioral biases at the heat of the moment all make good sense. Yet alpha is scarce. Eugene Fama showed that you only need a little bit of capital to arbitrage out inefficiencies and market anomalies. So it's my pleasure here today to introduce our panelists for what I think will be a very interesting discussion right at the core of how to think about a data strategy after COVID, if you like, as people increasingly say. We're going to talk about how to reliably build a data science strategy, how to optimize investment outcomes, and what kind of infrastructure is competitive these days. I would normally start in seating order, but in this new digital world, in alphabetical order. Our first speaker today is Mackenzie Hargrave. She's a specialist on the open FactSet content strategy team in New York City. In this role, she focuses on data integration and analysis of third-party data providers offered through Open FactSet, which won the Best Alternative Data Initiative in 2019 by Inside Market Data. Jesus Rodriguez is the co-founder and chief technology officer of Into the Block, a market intelligence company that uses machine learning and statistical modeling to deliver actionable intelligence for crypto assets. He was previously the chief scientist and managing partner at Invector Labs, and I believe a serial entrepreneur. Tom Taylor, he's the head of Alpha Technology and a partner at Numeric in Boston, a 30 billion quantitative equity and fixed income asset manager. Tom has been with Man Group for 10 years with a focus on building quantitative trading systems and managing high-performing technology teams. He was previously at Morgan Stanley. And last but not least, Ravi Trivedi. He's the AVP of Innovation and Decision Sciences at Nuveen, building a cloud data science platform supporting AI initiatives in the firm. He's also leading their innovation technology program. He was previously the lead developer and lead data scientist at TIAA, managing data science projects. So thank you all for being here today. Let's talk about data strategy. How do you build a reliable data strategy? When you think about onboarding data, it's very hard and time consuming. How do you see the current landscape to start with regards to data and a data strategy? Mackenzie, maybe you want to start?
Sure, yeah. So in terms of the landscape, we hear from our clients all the time who have been experiencing the high and often hidden costs of data acquisition. It's time consuming, it's expensive, it's resource intensive at every stage of the process, from identifying new data sets, evaluating them, and moving them into production. To give you a sense of some of the pain points that we're seeing most often. In terms of identification of new providers, there are thousands of data providers on the market. So it's really difficult to weed through all of that information without resources to surface high quality and impactful data providers. On the evaluation side, only a very small fraction of data sets that are evaluated are actually moved to production. So for instance, a firm may look at 100 data sets a year and only move 20 to production. For a number of reasons. That could include maybe the data wasn't fit for purpose, their priorities may have changed, or the research idea wasn't as impactful as previously thought. And that's a hit rate that's really hard to improve. So the key really is to try to increase the volume of providers that can be evaluated in a given time period. And this is something that's easier said than done, especially for small and medium-sized firms that may not have an entire team to commit to onboarding and scrubbing data. And then on the production side, oftentimes the cost to load, scrub, and concord data to a central symbology model can overshadow the cost of a new feed. And that is oftentimes associated with the burdens associated with working with multiple data vendors. So across the board, we're seeing a need to expedite the identification and evaluation process and of new data providers and reduce the resources needed to put them into production. And one of the key things that we see there is that you can really suggest that clients lean on data vendors as partners to reduce some of these burdens in terms of pre-screening data providers, pre-linking them to a central symbology model, consolidating some of the billing and contracts and things like that. But at the end of the day, there really is a need to expedite how fast we can evaluate new data with so much entering the market and lean on data partners to do that.
That's such an interesting point. Thank you, Mackenzie. Jesus, what are your thoughts on data strategy and the current landscape?
Yeah, so it's interesting. These days we look at mostly crypto data sets. So from that standpoint, you can argue it's a relatively narrow lens. But I spent years of my life building quantitative trading systems in Wall Street, and when I look at the type of technology and data that we had back then, I mean, it was the technology was very limited, and the data sets were not as broad and heterogeneous. And today, we're seeing an explosion on both. The diversity, number, and size of data sets that we're dealing with is very large. Typically, into the blog, we add about 100 to 200 gigs of data per day and are hosting about several dozens of terabytes of data. And but at the same token, technology has come a long way. Right, so today we have technology that is way more efficient for storing data, for data accuracy, for creating an entire life cycle of data management, and that's important. In our specific case, the main purpose of the data we collect is for the training of machine learning and deep learning models. So that's another dimension to the challenge, which is you need to think about how to curate this data for training. The models would generate new outputs that are also retrofitted into the data set, and it's almost another dimension of the data lifecycle that you need to consider if your main objective is to create intelligent models on top of it, because obviously machine learning operates in a different life cycle than most software architectures these days.
That's very insightful. Tom, what do you see on the buy side?
Sure. I think both within finance and just kind of more broadly, a lot of firms are starting to see that data is a competitive advantage for them. I think one trend that I particularly see is that as organizations on the buy side, we're moving to more of an industrial scale data onboarding process. So this means more centralization of data onboarding, more specialization, particularly with technology and with data scientists. And really the goal is just to lower the total cost and the total time that it takes us to onboard data sets and get them in the hands of quants and portfolio managers who can determine if the data set adds any value. I think if you cast your mind back, say 4 or 5 years, text-based data sets such as filings were deemed quite a difficult data set to work with, and a research project may take months to actually go from data coming online in-house to actually a research paper that shows if it adds any alpha. I think now we're expected with APIs that sort of research project actually takes days to weeks, and we can really increase the iteration cycle then of our quant kind of process and get more alpha into production with less cost internally. I think the second thing I'm seeing is that a lot of open source tools and a lot of open source vendors are releasing tools to really help with the data onboarding process. Things like Apache Airflow have been taken up across not only technology, but also finance, which is really helping schedule data pipelines, as well as tools such as Apache Beam that are there to really help you build very bespoke data pipelines, but ones that sit at quite a high level of abstraction. I think finally, the trend that I'm seeing is data vendors are moving much more into the kind of business-facing end of the data pipeline stack. So they're not only providing the raw data, but also the mapping, and then finally the actual research environment that enables the quants to research the data set and see if it adds value.
Brilliant, thank you. Thank you for those insights. And Ravi, what are your thoughts on data strategy?
Yeah, thank you. Excited to be here. So if you look at a typical company, right, like what you'll see is there are multiple data systems, like multiple SQL servers, Oracle, and other type of databases, right? So the key part here is to simplify that process that is there where, each individual investment teams or specific sub-organization is having their own database and they're managing it in a different way. So I think when thinking about data strategy, I would look at like two kind of key components, right? Very simplified platforms at the high level. One is data lake and one is data science, right? So think about data lake as basically storing or dumping all your data that is there so that it's all in one place, right? Like being on the data science side, we always run into a challenge where we don't have all the data in one place. That impacts our automation, that impacts our performance, accuracy of models. And as we have to go to these different places to get data, our data that feeds into the models is not recent or live, right? So that creates a lot of challenges. So as we are building data strategy for a company, we should look at kind of going with this simplified platform and the right governance model, and exactly hit on that, right? So one is data lake, second is data science. And in terms of the tooling of the setup, right, as my colleague mentioned, like there's a lot of innovation going on in open source. So there are very inexpensive tooling that are available in open source. You can try to like start with that. And the way you go with the data strategy is like start with a main use case that you have, one use case, because what we have noticed is it's kind of hard to say that, oh, okay, we are going to move all of our data in data lake, or this is our data strategy, let's all go and build on it, because it will be then a multi-year strategy that, will only give you, like your goals will be accomplished in 2 years down the road, which a lot of investment professionals wouldn't like, right, as they like to move very fast. So start with a main use case. Let's say if the use case is to have fundamental or holding data, then only bring that in, right? And it's very good to partner with data vendors like FactSet and others, but still a lot of your data is sitting on your server. So it doesn't make sense every time you want to execute a use case, you go to some external vendor system, upload your data and things like that. So key is to set up a self-service model with governance where each of the individual guys could kind of bring that data set in data lake by themselves. So I think the idea is to put the right governance and use the right self-service models.
Makes a lot of sense. Makes a lot of sense. Thank you. You're all building towards having a coherent strategy and having a coherent model, and I'm very glad to see that. I think that's really important. From an organizational point of view, what do you think is the best way to effectively bring together investment professionals, data scientists, and data engineers to work together in a cohesive structure? How do you enable innovation without stifling it? Maybe Tom?
It's Christos. Yeah, so I think it's clear to me that neither a fully centralized setup and structure where data is isolated from the rest of the business works. Those centralized structures are generally slow-moving, cumbersome, and they lack the real domain knowledge that they need to be effective in the organization. But I think it's also clear that a fully distributed data onboarding strategy where you have independent data silos isn't the way forwards either. And in those, you frequently find that it's really hard to share data across the organization. And you also build up these kind of personal toolkits that really don't get you to that industrial scale. So I think one thing that's worked well for us is centralizing some data functions, but actually having embedded members of the central functions within the investment management teams. So that means that we have central data specialists who have domain knowledge about building data pipelines, but they also start building up that business domain knowledge. And it means that they can understand what the business needs and get it in the hands of portfolio managers and quants in a very quick way, while also maintaining standards.
Makes a lot of sense. we've all talked about the value of data. Having an industrialized data onboarding process is a competitive advantage. Companies that do it better, go ahead. How should we think about the future? Is the future a world where portfolio managers with the most data win? How should we think about the value of data from now on, now that some of it has become known and more commoditized? Maybe Mackenzie?
Sure. Thanks, Christos. So I think we're only going to see more data sets enter the market, and more data sets that were previously thought of as alternative are going to enter the mainstream, and we're going to see them adopted by more traditional firms outside of hedge funds and things like that. But at the end of the day, more data is really useless unless it's orthogonal and adds value to a given strategy. And with technology improvements, we're seeing scalable storage and more data, and as Tom mentioned, unstructured content being more accessible. But at the end of the day, our clients don't have more time. So I think the winners here are going to be the ones who are spending more of their time on the right data. And the key to that is going to be creating all of the efficiencies that we've touched on to evaluate new providers faster. And some of that is some of the hurdles that Tom and Ravi have hit on already, and also consolidating symbology and billing and contracting, et cetera, and those burdens associated with working with multiple vendors. But I think on the flip side of that as well, as a vendor, we've seen a lot of success from our clients who offer a little bit more transparency into what they're looking for. And I'm not suggesting revealing any internal IP or anything like that, but simple things such as coverage, history, their perspective on what they're looking for. And going hand in hand in that, I think we'll also see a lot more success across the board with a push for industry-wide data transparency so that buyers have more information up front before they even decide to trial a content set. Whether that be sample data, sample code, things like that.
Well, that makes a lot of sense, including code. Jesus, how do you think asset managers should stay ahead in the data game? What are your thoughts?
I think these trends of machine learning, deep learning, are going to become like electricity in terms of investment. So the asset managers that are able to extract actionable intelligence from data sets are the ones that are going to stay ahead. So rapid experimentation to me is a key differentiator of the more agile and forward-thinking funds, particularly quant funds, compared to maybe the slow moving ones. So enabling an infrastructure in which you can incorporate new data sets, test new ideas, new models, extract intelligence, and recycle that through with the appropriate governance is key, and technology is definitely moving at a very fast pace. One thing that we observe these days, because I spend half of my time in the investment side, half of my time in the Silicon Valley side, is how much the lines between what big technology companies like Uber, like Google, like Microsoft, the infrastructure they're building to run machine learning models, how is that looking so similar to what the Two Sigmas, the Citadels, the DRWs are building, right? They innovate, those architectures are looking very, very similar. As someone who has spent time at big tech companies like Microsoft and big quant funds, that wasn't the case 10 years ago. I mean, those architectures look completely different, right? And now a lot of the innovation that is being created by these data science labs inside an Uber or Google is being retrofitted into quant systems to drive to extract alpha from specific market signals.
The nature of quantitative investment has changed dramatically, and data science is becoming increasingly universal. I fully agree with that. I want to dive a little bit more into something a few of you have discussed on the volume of data and how to sort of ingest that. What particular SLAs, what metrics would you put in place, or do you have in place to monitor your data ingestion engine? And also, how do you think managers should think about data that kind of lose or decay the forecastability? How do you get rid of data out of your systems? Maybe Ravi?
Yeah, sure. Thank you. So I think I would start thinking about the individual metrics in your data pipelines. So think about metrics like, what is the average runtime? What is the success and failure of each kind of data ingestion? And at the entity or object level KPIs, you should look at what are the number of records being inserted every day, updated, deleted, what is the space utilization and the IO rates and things like that. So each of this, if you collect these 6 KPIs and metrics, what happens is you can create a dashboard to drive and see, how each data ingestion pipeline is performing. And depending on that, obviously you would have your monitoring and alerting. If something fails, it goes to a person who is supporting it. But usually what happens in traditional use case is if something fails, people work on it and they close that incident, right? So, but they don't do proper analysis, reasoning around why did that happen? Is it happening again? Is it going to happen again? So the next step would be to really think about building machine learning models out of this simple 5-6 metrics to predict, when your ingestion pipeline is going to fail, right? Because you have just this basic data that you collect around, how long does it take to ingest one table every day versus how many times it fails. So given that you have all this data collected for 6 months, you can build a fairly simple machine learning model that will predict accurately whether, your ingestion pipeline overall performance is good or not, right? I mean, there could be fundamental issues with the pipeline that somebody just did not build that data ingestion pipeline correctly, and they're going and modifying it every month when something fails. So I think about the SLAs in terms of the metrics like monitoring and alerting, but even on top of that, we should build out some kind of model from this matrix that will alert us before even it's going to fail, right? It will give us an idea about a day after holiday, it's high volume versus, usually the vendor is not sending the file on this days and things like that. So I would really think about, forecasting that with simplified metrics, and everybody who has data ingestion engine and pipeline, they collect this basic metrics. Thank you.
Brilliant. Thank you. Tom, what are your thoughts on the same sort of metrics to have in place to monitor your data ingestion and also alpha decay? What happens to data as they get quicker, sort of commoditized?
Yeah, sure. I think it's a really interesting topic because as we move and we are consolidating, I think, with the sort of data onboarding ingesting pipelines that you'd see at Google or Facebook, certainly in quant finance, you do need to start seeing your process as this industrial machine. And so collecting metrics, I think, on how many data sets you're onboarding, where the current bottlenecks are key. I think focusing a little bit more on the alpha side, so is the data that you're onboarding adding value to your process and is it orthogonal? I think making sure you're monitoring your hit rates, both in sample, so during the research process, how many data sets did you see actually added value? And then also actually in live trading. And there can be quite a big difference that you see, particularly with alternative data sets, where actually a lot of the value in the data is coming from historical restatements that may be visible in the research data set, but not actually in live trading. And so you really need to be able to onboard these data sets with a very low cost so that you can start trading them and then actually start monitoring them in production. I think as well, we're definitely seeing that certain data sets have a very short shelf life. So they do add value, but then quickly become crowded. And so in those instances, particularly monitoring of live performance and making sure that you're not taking on too crowded positions is really key. And having the ability to actually kill and deallocate alphas, which historically in quant finance, particularly at slower speeds, isn't something that we kind of did on an automated basis. Whereas now it's all about, if you've got 100 data sets, how do you know that they're all still working in the same way that they did on paper?
Makes a lot of sense. And yeah, alpha decay is something that is in all of our minds historically and now with the quicker ingestion of data. Thank you for those thoughts. At this point, I'd like to dive a little bit more into the whole infrastructure aspect. Supporting a large data infrastructure is a big undertaking in some ways, but also the entry barriers have become much lower in recent years with availability of cloud infrastructure, for example. I'd like to ask all of you in turn, what are your main sort of thoughts on data architecture and also on the cloud versus in-house versus hybrid question? Let's start with maybe Jesus.
Yeah, so I think, again, I'm going to try to answer mostly from the life cycle of machine learning, deep learning models. I think rapid experimentation, as I mentioned, is key. From that perspective, cloud architecture, particularly the big three, Google, AWS, and Azure, have built very comparable technology stacks that enable end-to-end life cycle of large data sets and machine learning models, from experimenting with a model in a notebook, ingesting a data set, validating accuracy. A lot of those technologies are built as first-class services in those platforms, so they're cheap and easy to use. At the same token, we're seeing a ton of open source technologies being released by the big corporate labs, by Uber, by Microsoft, by Google, and incorporating by Netflix, right? Incorporating those into either reference architectures or open source stacks into your pipeline is something that we have found very helpful. To give you a very pragmatic example, until a year and a half ago, the techniques for doing hyperparameter optimizations in deep learning models in AWS and Azure and Google Cloud were very, very basic. I mean, you couldn't do any sophisticated deep neural network with that. And there were a couple of startups, in particular one called Weight and Biases, that was used by OpenAI, that we looked at it and the technology was far superior. So we incorporated it into the pipeline for doing testing and hyperparameter optimization. The same Netflix a few months ago released an entire reference architecture of how to use notebooks all the way from experimentation to production at large scale, and we incorporated a lot of those practices, because as you have more and more data and more models, the small mistakes can have a big cost, right? So you have to be very careful of how you incorporate new technology. But to me, agility and experimentation is key, particularly if you're looking at it with a data science angle.
Makes a lot of sense. Mackenzie, your thoughts on data architecture and cloud versus in-house?
Sure, absolutely. So I think tack on to that, as a vendor, it's kind of incumbent upon us to meet our clients where they want to work. Should that be working with in-house data lakes, cloud native storage, or a hybrid of both? And something that comes to mind in this area is that it's often overlooked how much red tape our clients are facing in that transition to new technology and evaluating new content sets. So we do our best to evolve as their technology evolves and be able to deliver data wherever it makes sense for them.
Thank you. Tom, I know Man has a lot of infrastructure. Do you have differing thoughts on cloud versus in-house?
We do, yeah. So I think there's a place for both, and particularly I think on the buy side and financial institutions in general, a lot of what we do is either IP sensitive or client sensitive, and in those instances, we have a preference for in-house. We actually have a preference for in-house for our quant research platform as well. And I think that's simply because it's much easier for us if we've got an in-house data center to tailor the platform exactly to how our sort of quants and our researchers and our portfolio managers want to work. However, what we do is we realize that sort of burst capability is what you lose if you are heavily in-house. So we complement our in-house resources and our in-house clusters with the ability to burst out into the cloud. And I think that gives you a particularly best of both worlds. And it means that for instances where we just need resources for a limited period of time, let's say a week or 2 weeks, we can actually do that with relative ease.
Brilliant. And Ravi, your thoughts on data architecture, on the online services, the SageMakers versus in-house, and the security of each?
Sure. So, I would start by saying that there are pros and cons to each, right? So if you look at a typical investment company, a lot of the data would be in-house, right? So majority of the data would be there. There would be established connectivity to all internal data. So a data scientist or a new person that is onboarding in the company can easily query or access all the data. Versus if you look at cloud, it is very cost effective, but then it's hard to move everything together, right? So there is certain amount of effort to migrate, and that migration effort don't always succeed, right? Like it's a big effort. So I would say that this has to be done as a use case driven, right? With a bigger strategy in the mind. So like, for example, take one use case and the data set that it requires and automate that, right? And creating template out of that so that other teams or other companies could reuse that and have a governance process built into that, right? And then the second part is like SageMaker versus on-prem, right? So like the challenge with SageMaker, right, is that a lot of the times your data will be in-house and it would be very hard to access that. You have to go about opening firewalls and involve a lot of security networking folks to kind of help out in there. So what you should do is take one major use case and then try to move that data set into cloud, right? That's when SageMaker would be helpful to you. But I've seen company having both, right? So like there is an internal data science platform, and then as we migrate people to cloud-based platform, we have it pre-built as well, where they can simply move the people from one place to another place. But the simplicity is the key here. So like the user experience shouldn't be changing. So whether they are using Jupyter notebooks on their laptops versus using SageMaker, their experience should be pretty much similar, so that they can easily get started on what they're doing, right? And this data strategy shouldn't be like an impact for them that they would have to go through a big learning curve onto like how to use this system versus that system. So I think it's more about like a phased approach than just saying that okay, everybody will go to cloud, right? So there has to be some hybrid component for 1 or 2 years in the middle until you say that okay, now I'm ready to completely move to cloud, and it has worked out for me for a year.
There's a lot of interest. I see a lot of people from all sorts of different sizes of teams in the audience, from small startups to medium-sized teams or companies to the very large quant hedge funds. How do you think the cost, you all touched on cost, how do you think the cost function kind of differs depending on your team size? What can you do to reduce the infrastructure costs of onboarding new data in this day and age? Who would like to take this one?
I can probably talk to that. So in terms, again, building a state-of-the-art technology platform for data ingestion, accuracy, and governance is key. The better technologies, the more agile flexibility you have is going to pay dividends in terms of whether you're a small startup, like we're technically small startup, and we're hosting dozens and dozens of terabytes of data and adding hundreds of gigs every day, and that's possible because we built a state-of-the-art technology platform all based on open source stack. So paying attention to what a lot of the big innovative labs are doing in terms of their internal architecture. These days, the architecture that Uber uses, Michelangelo, is publicly documented. The same with Netflix, the same with Google, and there is all sorts of projects for doing this end-to-end life cycle of big data sets. So trying to leverage those big practices are super important. And these days, with a state-of-the-art technologies, you can get pretty far, even if you're a very small team.
Let's take one more person from the panel. Who would like to talk about infrastructure costs?
I can take this one. So I 100% agree. I think if you invest in your data onboarding pipelines, and that's everything from the kind of technology with storage all the way up to an API for mapping data sets, then actually you can control your infrastructure costs simply because you've got a kind of top quality data onboarding ingestion engine that you've got all of your users using. And so, for example, if there's a optimal way of storing data and sharing data, and there's a single way of doing that across the organization, then it's very easy for you to optimize that particular piece of data storage, and everyone then gains that benefit. I think secondly is metrics. So I think it's really key to understand how your infrastructure is being used. Is it being used to store the raw data? So is it the raw data files that we've downloaded from an external vendor? Or is it some intermediate data that can quite easily be regenerated? And I think without a good, deep understanding of where your resource is being used, and which requires high quality metrics, it's really hard to actually optimize. So I'd definitely say investing in metrics and attribution early on in your data strategy is very important if you want to scale the system in such a way that it's cost effective.
Makes a lot of sense, makes total sense. I have a quick question, a lightning round. If you can give me a one-sentence answer about the future. So a few years ago, it was all about alternative data. This whole wave of large data, alt data came to investment world and became the thing. Where do you think we are now with that? And most importantly, as data get more commoditized, where do you see the investment world going from now on? Where do you think is the advantage? Lightning round. Tom?
Sure. So I think firstly, alternative data is going to drop the word alternative. It's just going to be data. And then secondly, if I can, I think application in less liquid markets. So we kind of, I think, have started seeing alternative data being used in kind of alternative instruments. That will continue, I think. And so quant fixed income is for me the one place where I think we'll start seeing additional applications.
Mackenzie, the future?
Yeah, sure. So I think as alternative data becomes just data, we're also going to see really increased focus on scaling data infrastructure and holistically reducing the total cost of ownership from delivery, storage, connectivity within firms, reducing data silos, and anything that's kind of holding up that total cost of ownership.
Jesus, one sentence lightning round, the future?
I think every major asset manager is going to be a quant fund in some dimension. I think it's going to be completely quant infrastructures, data infrastructures are going to become completely ubiquitous, and the line between discretionary and quant is going to be very blurry.
Brilliant. And Ravi?
Yeah, so I mean, just any new data gives you an edge, right? So having more relevant data, it's great for the bottom line, right, for analytics and correlation. The key is how do we find correlation between what we are trying to do and the new data point, right? So data in future will always keep on coming from different sources. Today it's alternative, tomorrow it will be from some real estate data set, right? So the key is the correlation.
Thank you all. It's been great to talk about the reliability of how to build a data strategy, how to optimize investment outcomes, and all of the infrastructure components that come into that. I know we have we have a minute left, so if anyone has any concluding remarks, any main points that you didn't have the chance to make, now is your time. Any final thoughts by anyone? Brilliant. I think we will proceed to the Q&A then. Thank you so much.
Thank you.
Thank you.
We see a lot of questions already. Thank you to everyone that has asked the question. And as a reminder, you can still go to the Q&A chat box and ask a question of the panelists if you want to. We'll try to answer all of your questions. We will try to answer directly to you if there's no time to go through some of them and try to summarize them. We have a question about research and development time. How long did it take you to build a data lake to actually start building machine learning models that could produce value? And if I can expand on that a little bit, maybe you can differentiate a little bit between small teams and large teams and how they might leverage third-party specialist tools. Tom, you want to kick this off?
Sure, thanks very much. So, good question. At MAN, and particularly with AHL and Numeric, for us, we've been in the business of looking at data for 30 years. So I think for us, it's easy to say our data strategy has been quite long, and we've built up significant experience over a number of years. I think, though, for me, one of the keys is just to continually invest and keep developing your data science strategy. I think if I was to think about a new kind of business looking to get in the industry, I think given the level of expertise and technology know-how you need, it's going to take a significant investment. So anywhere between sort of 2 years to 5 years, I think, to start up kind of a brand new team. I think particularly hiring good quality talent is particularly hard.
Very interesting point. Jesus, do you have any thoughts on this topic, on the time to R&D development?
Yeah, thank you for the question. So I completely agree with Tom. They're different. So the investment could be considerable. The agility is key on this. So you definitely kind of start small and scale from there. But there are some roadblocks that are not very trivial to overcome and sometimes fall outside technological capabilities. One is data acquisition. I mean, many times acquiring relevant data sets costs a lot of money, and that's something that a lot of firms cannot absorb. Second, as Tom was saying, is talent. Finding good, when it comes to data science, the difference between good and great is, I mean, you can quickly see it. So finding great data science talent is very expensive and hard, and you're competing with big budgets on the other side. And the third one is research and experimentation. Right, it takes a lot of effort to stay up to date with the latest techniques and things like that you can apply, read the latest research papers, extrapolate those lessons to finance. And so those three roadblocks, in my opinion, are things that any data science team in the quant, in the investment space should overcome. A very related question about the volume of data. So how do you stop your data lake becoming a data swamp? Ravi, do you want to take this one?
Yeah, sure. Thank you. So one of the things that we do is, we identify exactly what data set would be important for us for a particular use case, and we only bring in that data, right, that we need. Now, we do have to allow people to bring a sandbox. We have to provide them a sandbox area where they could bring in whatever they want, but proper governance is required to kind of, let's say, every month review what is in the sandbox, and whatever is not needed, it's, to delete that, right? But I think the key is exactly knowing what data set you would need and then cleaning up the sandbox every often.
Mackenzie, what are your thoughts on dealing with the volume of data and the time it takes with R&D, especially through FactSet?
Sure. So I think there's two pieces of this. One is that as firms, our clients and other firms start to take on more and more data and more diverse types of data, it's really important to be able to make those connections between data sets and ensure that they're reliable throughout time and consistent through M&A and corporate actions and things like that. So I think really strong entity-centric symbology model is really useful for that. As the types of data is being diversified, it's not all at the instrument level. You could have company level ESG ratings or sentiment information. So having an entity-centric model will allow you to more easily aggregate information from instrument, security, entity out to suppliers, customers, partners, and things like that. So I think symbology model is key. And in terms of evaluating, really ensuring you have as much information up front before you even take a look at it and bring it in-house to ensure that you can kind of weed out content that isn't going to meet some of your minimum requirements and move through the evaluation process faster.
Brilliant. We have a very, very naughty question about budgets. I don't know if anyone wants to take that without giving away company secrets, but what's the size of budgets you observe in practice? And that doesn't have to be your current company. It can be your experience of the industry in general. Who wants to take this one?
I can answer from kind of, I guess, my experience and looking across the industry. And I apologize that I can't give a number here, but I think the answer is significant. And we know that many of the larger asset managers are making significant investments. If I look at Man Group as a whole, we have well over 100 quants and portfolio managers, a lot of which are looking at building systematic trading strategies. On top of that, we've got well over 150 engineers all supporting them in the front office. And a large proportion of what they're doing is looking at data and interacting with data on a daily basis. So I guess my answer is a significant amount.
I'll proceed to the next question, but if anyone wants to come back to that, please feel free to. We have a very interesting question about when things go wrong. So what do you do? And I'm going to expand on this question myself. If you can think both from the investment point of view, how do you think about attribution or visibility, explainability of models, particularly in the large data and machine learning space, but also from the infrastructure point of view, given this this panel today. Jesus, maybe you want to start?
Yeah, in the case of machine learning models, there is a constant friction that is, I think in machine learning theory, they call the friction between accuracy and interpretability. I mean, it's getting better, but in general, it means the models that are easy to interpret, that you can clearly see what they're doing, they're not very accurate, particularly in markets that are very complex to predict. Models that are very accurate, they're complex and very difficult to interpret. So that used to be like black and white. Before now it's getting, we're seeing a lot of shades of gray, like deep neural networks are getting more and more explainable and interpretable, and there are better tool sets out there. But my advice would be try to invest, if you're really creating deep learning models and sophisticated neural networks, be prepared to live in a world in which you cannot explain decisions, like because it's just hard to interpret. And at the same token, invest as much as you can in interpretability tools. So log everything. Try to build, there are tools today like InterpretML and all this that will help you trace the decisions of a specific type of models, and there is a lot of active research in this space. So try to leverage that as much as you can, but it's really, really, really hard. Brilliant.
We have a question about data sets specifically. So what's the minimum historical data and key data set attributes that a new data set or a new vendor needs to demonstrate in order to bring their data feeds into finance? What are your thoughts on length of history as well, point in time, other characteristics that are of use to finance? Maybe Mackenzie, this is a good question for the FactSet, open FactSet marketplace as well.
Yeah, absolutely. So for the open FactSet marketplace, we don't necessarily set like a minimum threshold for history and coverage just to join, because naturally, depending on the type of data, it'll vary on the amount of history that's the minimum amount of history required to backtest and ensure it adds value to a given strategy. So for example, a quarterly data set's going to need a lot more history than a daily data set as a minimum threshold. But at the end of the day, we don't see it as incumbent upon us to determine which data sets will or won't add value to our clients. Everyone applies things in different ways to different use cases on different scales. So we really have the open FactSet marketplace be driven by client interest. So what our clients are looking for is what's on the marketplace, and the requirements that they need are met by those providers, and those will vary by content set and from firm to firm. But one of the things that we do in terms of screening is to really go in depth in terms of the company that's providing that data. We want to make sure that the providers that we add to the open FactSet marketplace, especially on the more alternative end of the scale, are going to be around in 2, 5, 10 years to continue adding that, delivering that data to our clients.
Brilliant. I know we were almost out of time, so in the interest of sort of the breadth of questions that I see out there, I'm going to ask one very, very quick last one. What do you see, so from a new graduate from college that wants to pursue a career in data science and understands that data strategy is important, what technologies do you recommend they learn? And if I can expand on that in terms of skills, data science skills, IT skills, machine learning infrastructure skills. Ravi, I think I haven't asked you as many times as the others. What are your final thoughts on skills for new people coming into the field for the future?
Sure, thank you. So I would say that, get to learn Python and the whole ecosystem, because that has been a lot of tools and APIs being built around Python and its integration with a lot of different tools used in finance these days. Also, one thing that in school we don't really get to learn is the concept of data lake, right? So getting aware of, what is data lake, how do you push all the data to data lake, what do you do after that, would be very helpful. And anybody who is kind of new starting on the machine learning journey, they should think about explainable AI, as we talked about, and responsible AI, right? Just because we have a lot of data doesn't mean we can use that in our models. So those two concepts will be very useful if it's being learned from the beginning. Thank you.
Brilliant. I know we're running out of time, so I want to leave time for all of you to make it to the next sessions. I thank you all. Thank you all to our speakers for being here today and for sharing all your very interesting thoughts. Thank you to all of the attendees and for all your really interesting questions across the board, from investment to data to infrastructure and the new graduates, the future. I really appreciate that. And enjoy the rest of your digital week. Thank you.